All of you can? Okay, so today we will discuss polymorphism and virtual member functions. But before that, okay, I think we should not come to definition yet. But if simply polymorphism means poly means several and morphism means types or shapes. Anything which can have several forms. Okay, this behavior is called polymorphism. So why polymorphism comes to C++ and why we need polymorphism in C++? So to come to this point, let's come to the book. Uh, if all of you can open the book, then will be quite better, because I am mostly referring to the book, because the book has too much explanations and examples, and all the examples I have already written and I will share with you. So the book page is 929. Okay, so here under the polymorphism and virtual member functions, don't worry, we will define again. But simply if you look at this definition of polymorphism, that you see polymorphism allows an object reference variable. Okay, and you see now maybe you will be confused, what is object reference variable? I hope you should not be. If you are confused, later on I will explain. Okay, so this phenomena allows the object reference variable or object pointer to reference objects of different type. Different type means that may be base class object or derived class object. So it can change the shape. It can allow both type of objects to call a correct member functions depending upon the type of object being referenced. I am very sure you didn't get this definition. Okay, so don't worry, no problem. Here I am sharing one code first. All of you can see this one. Note this point, that this example we will use many times. Okay, so please try to understand the example first, because this example I am using many times later on. Okay, so here we have the class grade activity, and it has a protected data member score. In a public area, one constructor and overloaded constructor, and then a set score function and get score function. And this is the most focus function that we will focus on this one. Note, please very clearly observe this function. This function is declared inside the class. Character, its return type is character, and get letter grade, meaning to say there will be a student marks, and on the basis of the marks, this function will tell us the grade of the student, and the grade will be in the form of character, like grade A, grade B, grade C, like that. So this function is declared inside the class, and outside the class, here it has been defined. So I hope you know what is declaration. Just to introduce to the compiler, and the actual coding is called definition. And I hope you still remember that the class name and the scope resolution operator links this definition of the class, definition of the function back to the class, meaning to say this function belongs to this class. Okay, now focus on this point, that this character, this function is checking the marks, and on the basis of that it returns the grade later. Okay, so if the marks are more than 89, then will be grade A. If more than 79, then B. And if more than 69, then will be C. Note this point. You see this 37 and 38 line. In the coding, this will be used later on. Okay, so if the score is more than 69, then will be grade C. This is a base class function, get letter grade. Okay, after that we have another class, pass fail activity. This is a derived class, derived from publicly from grade activity. It will get the other stuff from the base class, but it defines extra something. This one is the minimum passing score, that in each subject the minimum passing score is what. After that, the constructor. Okay, so when you see on this line, when the derived class constructor calls, okay, and when it runs, it call the base class constructor also. If you have forgot how to call base class constructor from derived class constructor, we use this colon, and after that the base class constructor and the parentheses or brackets. So this colon here doesn't mean inheritance. Here it means calling base class constructor, and it initializes the minimum passing score. Then derived class constructor, okay, it again calls the base class constructor. Okay, then a set minimum passing score function, it sets initializes the passing score value, and this one is the get passing score function. It display for us, it return back for us. And you see here the same function, get character grade. Note the point, you see the same function was in base class also, right? I hope you still remember. If you don't remember, let's quickly go back. You see this is the function, get character grade, get letter grade, and these are the details. So the same function is redefined in a derived class. So note this word also, redefining base class function in child class. Okay, so this one is again declared here, and here outside the class is defined. But if you remember the previous one, here was in here the focus in the child class, the focus is on pass and fail. Okay, because this is pass fail activity. Okay, and in the parent class, in the same function, the focus is on grade, that grade A, B, C or D. Okay, but here the same function name, but the focus is on pass fail activity. So later on we will recognize these functions. If the function return as pass fail, it means this is the child class function. If it return as a grade A, B, C, so it means it is a base class function. Please note this point. This is why I was keep telling you today I need your attention. Okay, so here another class, third one, and this class is derived pass fail exam, okay, from pass fail activity. So you see this is now a third level inheritance, grade activity, pass fail activity and pass fail exam. Okay, you can somehow say like multiple inheritance, but it is not too much multiple inheritance. It is a class hierarchy, like class A, then B is derived from A and C is derived from B. Okay, now in this pass fail exam activity, it has these three private data members, that number of questions. For example, if there is a pass fail, if there is an examination, okay, So in the examination, how many questions are there? Okay, and the second one, points each, meaning to say each question is having how much marks. And the third one, number of missed, means that some student miss some questions, some student cannot do all the questions. So how many questions any student missed? These three variables. Okay, now again a constructor which is calling base class constructor also, and again another overloaded constructor which having three arguments, and then call the base class constructor. And you see the one object, the one argument which is here, from here it is passed to the base class constructor. And again here it is called set. Okay, questions and missed. So set, the set function is called from inside the constructor, and that function is this one, that set. Okay, int this one and this one, so this will be defined outside the class. Okay, now get number of questions, get points each, and get missing number. So these are get functions, and this one is the set function which was called by the constructor. So this one is setting, you see, the number of questions and number of missed, how many have you missed questions. Okay, then the points are calculated from these two values. That if, let's suppose, the subject has 100 marks, so number of questions were how many, then just divide the 100 by number of the questions, then you will get each question mark. For example, let's suppose the exam has 5 questions and the subject has total 100 marks. So 100 divided by 5, then each point will get 20 marks. And here numeric score will be calculated like this, that 100 minus how much points each question has and how much you have missed, then this will be minus from the 100. For example, let's suppose out of the 5 questions you miss 1. Okay, so the one has, the missed will be 1 time 20 minus 100. So 100 minus 20, it will be 80. So the minimum, the numeric score will be 100 for that student. Okay, so set score function is called again, and then this function, this function is also very important. Hello guys, I need your attention until this point. Okay, any problem? Should I go back, define, explain any function or any coding? Any one of you so far? Okay, huh? Okay, now if okay, good, great, please be with me. Here a little bit technicality comes in now. You see, here is a general function. You see this one, this function doesn't belong to any class. Line number 140, the class function, the function, its name is display grade. This is general function. General function, I mean that this we will define in the main or outside main, but this function doesn't belong to any class. Okay, so now we just declare the function, but here is one point. You see, its argument is const grade activity. Can you remember the grade activity is which class? Derived class or base class? Any one of you? Yeah, base class. You can say something like a grandparent, okay, because it is the very base one. Okay, what's the question? Someone is asking, what does, yeah, I am coming to this point. Yeah, yes, little bit wait. I am coming to this point. Okay, so the grade activity is the base class. This ampersand or the address operator means that when we call this function, we will send one argument to this function, but that argument will come to this function as a reference. So you see, in the polymorphism definition there was a word reference object or pointer. Okay, so here actually the polymorphism will happen only in this function. Okay, so uh, this I am repeating once again, this address operator is saying that the argument will send by reference, not by value. I hope you still remember. By reference means that actually the object will be not sent as a whole as by value. No, only its address will be sent to the function, and then that function will get the access through the address and can access the object members and the object functions. Okay, so this show that the argument will be sent by reference. Okay, after that int main starts, but I think before starting int main, let's go to the definition of this function. This function is defined after int main. Okay, when you are defining after int main, then you will have to declare first, like in this case. And when you are defining before int main, then no need of declaration. If you just copy this coding and paste before int main, then okay, then meaning to say a compiler reaching to the int main, it will already compile this one first, so then compiler can understand. Okay, now in the definition of function means the actual coding of the function. So you see, is the same thing, grade activity, but here the reference, and this is the argument name. You can change this one by any name if you want. You can change to anything like ABC, anything, or object, whatever you want. Okay, you can change. But this address operator play the important role that the object will be sent by reference, not by value. Okay, so what will happen? So this one is just set precision, okay, to set the decimal point value. And then you see activity is the object reference, okay, dot get score function. Okay, so the object which is sent to this function, the object may be base class object, the object may be child class object, the object may be any like grandchild object, so anyone. So normally base class and derived class object can be. So that one is calling the get score function, and that one is calling the get letter grade. Note the point, you see this get letter grade, this is defined in base class also and in derived class also. So our focus will be that when this get letter grade function is called, let's see that base class function, base class version is called or derived class version is called. This function is clear until now? Hello guys, anyone, any question? Otherwise I will explain again. Is clear, huh? Okay, good. So if it is clear until this point, I will, let's go to int main. This is the int main part. Okay, so in int main part we are creating object of pass fail activity. Pass fail activity, remember, that is the derived class. Okay, and its object name is test. So this is the object, this is the class name, and constructor will be called, and we are passing the minimum score as 70. Okay, so now you see that test score, test dot set score is called again, and now the score will be set to 72. Okay, now after that the function which display the grade, we are passing, you see the object we are passing here, the test object, which is child class object, we are passing in the argument. So we are passing this object uh, as a reference, because you see here, when this line 153, this line is called calling of the function. So when we are calling the function, actually it is not clear here that the object is sent through by reference or the object is sent by value. It is only clear during the declaration time and definition time. If here is the ampersand and the address symbol, it shows that the function, the object is sent through a reference. Okay, so if I call this, if I run this function now, oh, if all of you want to get this coding, let me share with all of you. Sorry, I should share with you earlier, but I didn't realize. Okay, just click this link. All of you will get in the chatting. I give the link. Just click this. All of you will get all the coding. Now let's run. Okay, if I click run, you will see the, if you look at the output, the activity is numeric score is 72 and the activity grade letter is C. Can any one of you tell me which function is called? The get letter grade function, get letter grade. Which function is called? The parent, the base class function or the derived class function? Let me go back. Okay, you see, note the point, the score is more than 72 and the grade is C, and we have we have object of sorry, we have object of pass fail activity, pass fail activity. Then go up, go to pass fail activity. Here you see, this one is the class pass fail activity. Inside the pass fail activity, the function get this one, get letter grade, and this is defined outside the class. So you see here is no C and no the focus is on only pass and fail. P, if the score is more than minimum passing score, okay, then you display pass, and if the score is less than minimum passing score, then display fail. but we are getting a result. If you see here in the window, output window, here we are getting letter grade equal to C. The object is pass fail activity object, but we are getting output from base class. What's the reason? You see, if you go to base class, you see here it has been mentioned that if the marks are, the score is more than 69, then return C. You see, we have here return C. So it is the base class function is called. Even though we created derived class object and we send to the grade display function the object by reference derived class object, not base class object, but still the function is called base class functions because we are getting grade. We are not getting passing or failing criteria that the student is pass or the student is fail. So the reason is what? Why it is called like that? The reason is that you see here, yeah, some student, you can unmute yourself. So the base class is grade, yeah, grade activity. Yeah, where we, yes, exactly. The base class is grade activity. Okay, so in the grade activity is focus on grades, grade A, grade B, grade C, and in the pass fail activity the focus is on passing and failing. Okay, pass and fail, P and F. Okay, this is why there are two grade activity. No, there are not two grade activity. You see, let me quickly go once again. You see, this one is grade activity, right? The parent, the base class. This one until this point. This one is, you see, pass fail activity. This one is pass fail activity. Okay, and third one is passed fail exam. Yeah, the function is the base class function is called, but the question is why base class function is called. We want to get information about the derived class. Okay, because the object here in the main function, the object is, you see, pass fail activity. This pass fail activity is derived class and the object is also derived class. So the information should come from derived class, which is about passing and failing. It should, we should not get the information about grading because the class name is pass fail. We want to know that the student is pass or the student is fail. Okay, so the reason is that in this grade display grade function, the the argument data type is what? Can you see? Grade activity, and grade activity is base class. Okay, so base class, if you remember, we can assign, okay, like this, that from the is a relationship, if you remember that one, from the is a relationship, child class is a type of base class. For example, pass fail activity is a grading activity. Okay, you see, I am repeating once again, pass fail activity is a grading activity, but the reverse is not possible. Grading activity is not pass fail activity. Like this, that any assignment is grading activity. A midterm is a grading activity. Final exam is a grading activity, but only quiz or only assignment is not pass-fail activity. Only on the basis of assignment you will be not uh, totally pass and not fail. So the reverse is not possible. So the is-are relationship doesn't work in a reverse. Like this, that undergraduate student is a student. Okay, undergraduate is a student, but every student is not undergraduate. I hope is clear. So meaning to say, we can send derived class object to this function because it is a type of this. Okay, but what compiler do when compiler see this declaration of the function, then compiler decide on this. Note this point, compiler decide on compiling time that any object which comes here, all the functions from base class will be called. Compiler already decide from this word because this is base class data type now. So compiler decide during compiling time that all functions from base class will be called, even though if we call through derived class object, still it will call base class functions. And this decision which is made during compiling time is called static binding. So one is static binding, one is dynamic binding. Okay, so let's link this one with polymorphism. So you see, we are calling through derived class object, but it always call base class function. If we call again with base class object, it will again call base class functions. So it doesn't perform in many forms. It always perform in the base class functions way. So it has only uniform, not polyform. Okay, so here is a problem. We cannot get polymorphism. We want to get different version. By different version I mean that if we call through derived class object, we should get derived class version, and if we call base class object, we should get base class version. We want two different behavior, two polymorphism, but actually we cannot achieve. So this is the problem. And the problem is the origin of this problem is the decision of the compiler. That compiler decide at compile time. Okay, and the compile time decision is based on this word that compile is watching, that it is base class word. Okay, and this decision is called static binding or early binding. Okay, these terminologies are quite famous, and you should be clear about that. Until this point, any question? Hello guys. Yeah, static binding I already defined. Kavin Raj, I already defined. Is it clear now or not, or I should define again? Okay, now is clear. Anyone else? Okay, so let's link this concept again with polymorphism. Polymorphism means that one function should behave differently. So the get letter grade is one function, same name, but one time we want that the same function should tell us about passing and failing, and if we call through base class constructor, the same function should tell about grading. So the function name is same, but the result from derived class point of view is different, and from base class point of view is different. So if the program behave like these different uh, in these different ways, then it is polymorphism. And if it cannot behave like that, if it always give us base class version, that then it means that it is not a polymorphism. And the main reason is the static binding that compiler decide on compile time. Okay, now what's the reason, and how what we can do to go to polymorphism? If you look at this, okay, so this is the polymorphism, and to polymorphism we need a virtual member function. Okay, note this point. So what is a virtual member function? A function in a base class that expect to be defined in the derived class, meaning to say virtual function must be defined in a derived class. One point. Another point, virtual function defined with the keyword virtual. We will define such a function that from which we expect polymorphism, multi-behavior, then that function we will for that function we will use the word virtual. Okay, and when we provide this, then it support dynamic binding. Okay, and dynamic binding is what the function bounds at runtime. Okay, compiler don't decide which version I will call until it reach to the running time. At runtime it will look at the object. If the object is from derived class, it will call derived class function. If the object is from base class, it will call base class function. So the decision is not done early. Okay, the decision is postponed until runtime. So this is also called late binding, okay, or dynamic binding. Okay, so to how to do this and how to define these virtual functions, let's go back to the coding. I have already designed this project. Yeah, leave this one. Okay, then dynamic binding. Okay, let me share with you from now. Copy. Okay, all of you get this one. Okay, actually in this new coding, in this new project, only one word is different. Okay, the let's go through. The grade activity is the same, the constructors are the same. Okay, uh, overloaded constructor, the mutator, all these are same. One word is changed. If you see the line number 26, there is one word virtual. Hello guys, can you see? Okay, I hope all of you can see. Okay, so now you see the base class function we make is virtual. Okay, so now the get letter grade function is virtual function. So what does virtual means? What is the role of this function? The role of this function is that first of all the base class expect that every derived class will redefine this function. Okay, will redefine this function. Okay, so in a derived class, let's come, you see. Okay, another point, during declaration time you will use the word virtual, but when you are defining the actual coding, then no need to again say virtual. Only one time is enough. Okay, so this is the base class and this is the only change. Now pass fail activity class, come to this one and come here. You see, in a child class also, again the same function get letter grade is virtual. Now if you here, if you don't type virtual, actually due to the base class virtual, it will be automatically virtual, but the best practice is that you must put virtual, because when in a parent class this function is virtual and the child class are redefining the same function, so actually it will come as a virtual. Okay, but the best practice that we should put virtual, then it is much more clear if someone want to read it. And again, the virtual word is only needed during the declaration time. It is not needed during the definition time. And you see here again, here in the child class the focus is on passing and failing, and in the base class the focus is on grading, grade A, B, C, D. Okay, now the pass fail exam, it is the same thing. Everything is the same here, until even everything is the same. You see, even the display grade function the same. You see, the parent uh, class argument, it is still the same. Okay, meaning to say we can send to this function derived class object also and parent class object also, but as a reference. But when the function has a keyword virtual, then compiler don't decide at that compiling time. Okay, compiler wait until see the object, which object is it. Okay, so if we go to the, you see, if you go to the definition of this function also, this one, where is it? Yeah, this one. You see, it is 100% the same, nothing has been changed. Okay, if you go to the main function also, it is also somehow same, but only there are two objects to show that one time parent class will be called, parent function will be called, and one time derived functions will be called. So the first one, line 149, grade activity is parent class. Okay, and test 1 and the score is 88. Pass fail exam is a derived class, test 2. Okay, in a test 2, if you go to its constructor, it needs 4 arguments. The one argument, the first one is the 100, is the total marks of that subject. Okay, and the score and the marks for each question. Okay, now after that, you see display grade, we are passing test 1, this time passing parent class object, and again the same function is called when we are passing test 2, and this one is the pass fail exam object, this is a derived class object. So when we run this one, okay, let's run. When we run this object, you see in the test 1 the focus is on grading, grade B. Okay, and in the test 2 The focus is on passing and failing. Now the function name is one, get letter grade, okay, but it behaves differently for different objects. When is derived class object, then different function is called, and when parent class object, then different function is called. So it's like poly poly behavior, polymorphism, okay. It behaves in different or many ways. So this is called polymorphism. Hello guys, until this point, any question, any one of you? I hope you are not sleepy. Okay, good. Not sleepy. Okay, good. Oh, I am so happy that you understand what I was saying. So nice, really so nice. Do you want some break or we should continue? Break or continue? Yes, sir. I don't know. Yes means break or no, or continue. Okay, break. Oh, some says continue. Some, can we have 5 minutes? Yeah, I think you should take 5 minutes break, and after that we will. Okay, so we were discussing polymorphism. Did you realize that what is needed for polymorphism? If we want to get a polymorphic behavior, what are the requirements? What, when we can achieve polymorphism? Yes, this is one criteria. Very good. And address operator. Yes, good. These are the two criteria that the functions that from which we expect polymorphic behavior, that function must be virtual, and then the other function where we want to display the contents, that function must be sent uh, through reference. Now if you look at the definition, I hope now you will understand. Let me read. You see, polymorphism allows an object reference, okay, object reference variable or object pointer. We will discuss this later. So now object reference variable to reference objects of different types. You see, a reference object of different types. In the function, we have used the word grade activity, parent class, but actually we are using reference, so it can refer to base class also, it can refer to derived class also. So it allow the object to refer to different type and call a correct member function. Correct member function, if the object is child class object, then call child class function. And if the object, the reference is derived class, no sorry, base class object, then call base class function. So polymorphism allows an object reference variable or object pointer to reference object of different types. Okay, this the types is related to the address operator. This keyword links to that one, and the other one, and to call the correct member function. The correct member function property we can achieve by the virtual word, depending on the type of object being referenced. Okay, so this is the all the coding. You see, all this coding I already run for you. These were the two type of coding, all the details. Okay, you place, yeah, okay, all these things we have covered. Let's go through. the grade activity, yes, go through. Yeah, until this point, you see, um, this was our output, the same test 1 and test 2. Okay, because I am following exactly the book, so this is why it is same like that. Now you see, polymorphism requires a reference or pointer. Okay, so when you are calling the function, so you will call the function through a reference, okay, or through a pointer. You cannot call the function through a value. Okay, and here actually it gives one example where it calling the function through a value, mm, which doesn't work. Okay, let me check if I have that one, then I will run for you. My projects. Okay, so static binding, dynamic binding base class, dynamic binding pointer. I think I don't have. Okay, so here it only understand base class. uh, Sorry, it needs uh, a pointer or reference variable. Okay, second one, base class pointer. Now reference variable or pointer, it is the same thing. Okay, uh, only the function is called with different with a pointer, not with a reference variable. Okay, let me show you through the coding, then hopefully will be clear. Dynamic binding pointer, yeah, this project and this project, if I should share with you. mm, okay, so this is the code you can get from this link. Okay, now here, if you look at this coding, actually it is the same grade activity and all things are the same virtual. Okay, everything is same, only one thing is changed. That one is the pointer. Can you remember previously that in this function previously here was address operator? Do you remember that? So when in the function bracket and in the argument list, yes. So that was address operator. Now we are using asterisk, the star. So the star is for pointer. It is not for reference variable anymore. And I hope that you still remember what is a pointer. Pointer is a variable which can store only address of other variables, but in this case the variables are object. So here the pointer means it is an a variable, or it is yeah, we cannot say object, it is a variable, a pointer which can store address of other object only. Okay, so in the definition also the rest of the coding is 100% same, only here in place of address operator asterisk is used. Okay, but here in the main function you see the test1 test2 are the same, but here you see the test1, when we are sending, then here we are using the address operator. What does this mean? It means that we are sending this test1 address, not the test1 by itself. Okay, you can see in the command address of the grade activity object. So address of test1, so the address of test1 will go, and here is a pointer, and pointer we know that it can only store address of something, then it can the address will be copied to this variable now. So now you can say that the activity and the test1, actually it is two names of same memory now. Okay, the memory where the test1 object is stored, its address is sent to this one also. So now it, both of these two words, the test1 and the activity, refer to the same memory location, to the same values. And one more difference is here, that if when you are calling a function through a pointer, then you will use pointer access operator. Okay, here is a difference. Previously here was dot, and now here is an arrow. Okay, so this is another difference, the star and the arrow only. Previously here was a dot. So note another point, that whenever we want to call a function through a pointer, then we will use arrow operator, not the dot operator. Okay, and now if we run this coding, the result is 100% same as like the previous one. You see, in the test1 case is grade B, and in the test2 case is passing and failing, because in the passing, the second one is a derived class. Okay, in the derived class is a pass fail activity. We want to know pass or fail. The previous one is grading activity. We just want the grade. So the result is the same. So meaning to say, we can get polymorphism through a reference or a pointer, So this is why if you go to the definition, there was or in the definition, that object reference or object pointer. Okay, so this is the same thing that I run for you. You see B and P. Oh, here is another one. Here is just a little bit difference. I think I have this one also. The only difference is that here dynamic base class pointer. Yeah, here in the main function everything is same, but in the main function it creates an array. Okay, I hope you will understand. Let me try to explain. This is the only difference. The rest one is the same, like the pointer version. Number of tests, meaning to say this is a constant variable. Constant variable size is for this one, we will use for the array size. And you see grade activity test asterisk tests. So here the asterisk means what? It is again a pointer to array of objects. This tests is an array of size 4, but the pointer means actually this is a pointer to an array of objects. And this array is automatically initialized in these curly brackets. And if you look at in the initializations, the new word is used for dynamically creating objects or dynamically creating variables. Okay, so new means it will dynamically create. Dynamically means when the program run, during runtime, it will create what? A grade activity object, a grade activity object. What will be its name? Every object has a name, right? So when this dynamically created the object, what will be its name? Actually it will be somehow like the compiler will maintain some dummy type of names or no names, but such a names that only the compiler will maintain to keep the memory. Otherwise we don't know here in the coding what will be its name, but the compiler can take record of all those. So the compiler will automatically give some name to this object. The second one is a different object, pass fail exam. You see, pass fail exam. And the third one is the grade activity, and again pass fail exam. Okay, so in this case we have four objects in this array, two of grade activity and two of pass fail exam. And here uh, actually it calls the display function in a loop, meaning to say four time it calls the loop. Okay, for first time for the first object, second time for the second object. So every time this function will be called four times, and its display will be four different values, or four different objects. So if you see here, you see test1, okay, and it is about the grade activity, the parent class one. Test 2, it is about passing and fail, so it is pass fail activity, the exam one. This one is again about the parent parent class object is called, and at the fourth time again the derived class function is called. So meaning to say, if we have as number of objects and dynamically call the functions, so the compiler is able to decide dynamically at runtime which function should be called, and the different functions will be called based on different objects. So this is why it is a polymorphism. It showed different behavior to different objects. I hope now is somehow clear, huh? Any confusion, please you can ask. Okay, here is one other problem. The problem is about the pointer and about the references. You see, the base class pointer and reference knows only about the base class members. What does this mean? It means like this, that you see in this function sorry, in this function the base class pointer is here, or the if we use the ampersand, okay, the address operator, then will be base class reference. So the base class reference and the base class pointer only know about parent class functions. It means that if there is a function in a parent class and the same function is redefined in a child class, so then it's okay, because the parent class also has a function with the same name. So okay, no problem. But if there is such a case that, let's suppose the parent class has two functions and the child class has three functions, okay, then this pointer only know the two. It cannot understand the third one. If you look at this coding, you see here, can you see this coding? That grade activity is a parent class and the exam is a pointer for grade activity, and we are assigning, dynamically creating pass fail object. Pass fail is a derived class and its address is assigned to parent class pointer. So using this parent class pointer, we can call get score. So it's okay, no problem, it works. Why? Because get score is present in parent class. We can call with the same pointer get letter grade. It's okay because parent class has this function, no problem. But if there is a extra function in a child class get point each, this is extra class, sorry, function, extra function which only exists in derived class. So with this pointer, if you call, it will give you an error. You cannot call with this. Okay, so this is why, you see, this is why the is a relationship doesn't work in a reverse. So like as I told you, that undergraduate is a student, but every student is not undergraduate. So you can say like this, that the final exam, no, sorry, the pass fail exam is grading activity, but grading activity is not pass fail exam. So this is why with the pointer of grade activity you cannot call a derived class function. So the reverse is not allowed. Okay, this is why the pointer only know about parent class functions. I hope it is clear. Hello guys, it's a bit becoming challenging. Any question until now? Oh, okay, good. I am that much good that I am explaining better, or you are that much good that you can understand? I think you are so good. Yeah, this is the coding I have. Yeah, this coding you see here. Here is one problem. You see in the main function, can if you can see in the main function, here is the function which is called get point each. So if you search this one, I'm not sure this editor provides searching or not. Yeah, okay, provide searching, search. Yeah, so this one is where you see get points each. So this one is inside, inside where, inside pass fail exam. Okay, so this is inside pass fail exam, and there is no function with this name get points each. With this name there is no function in parent class. So this is why here in int main, the exam pointer, this exam pointer is derived class pointer. Derived class point, no, sorry, base class pointer. Base class pointer only know about base class function. So this pointer can call get score. It is present in base class, so no problem. It can call get letter grade. It is present in base class, no problem. But the get points each, this is only present in derived class. It is not present in base class, and the pointer is of base class. So base class pointer cannot access derived class functions. Let's try. You see here is an error. The class grade activity has no member named get points each. So it means the grade activity, the pointer only looking for grade activity functions. It cannot look for derived class functions. If you just comment this line, okay, and if you run again, then is okay, no problem. Yeah, it will run, it display the coding. Okay, so this is the point that the is a relationship doesn't work in a reverse. Okay, doesn't work in a reverse. Okay, so let's proceed. Okay, one more point. Redefining and overriding. Redefining and overriding means what? Like here, that derived classes can redefine base class member functions. We studied this. When a class redefine a virtual function, it is said that the class overrides. override means the same like replacing that version. Okay, override means like replacing the base class version, and redefining means that the base class version is also there exist, and the new version is also there, so both version exist. But in case of overriding, both version doesn't exist. Parent have separate version, child have separate version. In child, both version doesn't exist. Okay, in C++, difference between overriding and redefining base class function is that overriding functions are dynamically bind. Okay, note the point that the polymorphism is only happen when the functions are overridden. The functions are not redefined. And how we will know that it is overridden? The overridden function property we can get if we use the word virtual. If the word virtual is there, it means the function will must be overridden. It will be not redefined. So note this point, note the difference between redefining and overriding. Okay, so we are discussing the concept of virtual functions. So destructor, I hope you still remember, destructor is also a function, right? So there should be virtual destructors also. If there is a polymorphism, if one class is derived from another class, then and if the base class has destructor, okay, then the destructor should be virtual destructor. Okay, if it is virtual destructor, then it will clean the child objects from memory successfully and the parent object successfully. And if it is not virtual destructor, then it will only clean the parents one, because you see, if there is no polymorphic way, then it can only know about the parents one. Let me show you through a coding. Hello guys, you are not bored? Is okay? Any confusion? You are with me? Okay, okay, good. So virtual destructor. This is the coding of virtual destructor. Let me share with you also. You can get by this link. Okay, now this one is quite simple. You see, one is a class. Did you open? I think I should give you a few seconds to open. Otherwise, just look at my screen. Okay, so there is one class animal, and it has a public constructor, and in the constructor we are just displaying a message, animal constructor executing, and it has a destructor. Okay, but you see, note the point, it is normal destructor, it is not virtual. There is no any virtual word here. So here is a message, animal destructor. So animal constructor, animal destructor. Then another class with name dog. So the dog is inherited from the animal publicly, and it also has one constructor and one destructor. Now let's come to the main function. You see, in a main function, we are creating, this is what? Pointer of base class. Pointer of base class, which is animal class. And we are assigning what? New dog. So the new word is dynamically creating object of dog class. Dog is a derived class. So derived class address is assigned to parent class constructor. Sorry, parent class pointer. Now we want to delete the object because destructor is automatically called when the object is deleted. Okay, so we are manually deleting the object. Delete my animal, the pointer. Okay, now let's see during the creation time when the object dog is creating, the constructors will call. So which constructor will call first? Any idea? Hello guys, any idea? Which, yeah, very good. uh, Parent constructor will be called first, the animal one. Then the dog constructor will be called, and when the destructors are called, then the order will be in reverse. First child destructor will called, then parent destructor will be called. This is a principle. But in this case we are using pointer, and pointer only know about parent. Okay, if the pointer is parent pointer, it only know about the parent, it doesn't know about the child. So let's run, then you will realize the difference. First, you see, animal constructor call. First time, first parent created, then child created, and you see, animal destructor executed. Even the child destructor not executed. So the child object is still there in memory, and actually it is such an object which don't have any father, any parents. Okay, so it's big glitch and a big mistake if you do like this. So the mistake is what? The mistake is that we the parent has a destructor, okay, and we are using parent class pointer. So in such a case, the parent class uh, destructor must be virtual, otherwise it only know and it will only clean and delete only parent object. It will not delete uh, it will not delete derived class objects. Okay, the correct version of this is the other one. This virtual destructor 2, and here, yeah, the only difference is this one. I think you can simply put the word virtual, or if you want I can share the coding with you. Okay, this is the coding. The only difference here is what? That you see, when the base class constructors were defining, then we use the word virtual, because the reason is, why we are using, the reason is that parent class pointer only know about pointer, and we need such a destructor which could clean parent class object also, and which could clean derived class object also. Okay, so this is the only version. You see, in a dog class, the destructor is, because there is different destructor, here is different destructor, so no problem. But when the parent one is virtual, okay, then it in the child it will be also virtual, and then the compiler can decide better. And now if you run this one, then the result is different. You see, even third line, you see, first first parent is created, then child is created, then you see first child is deleted, previously the child was not deleted, and then the parents are deleted. So this is another point about virtual word, that if there is any base class destructor, okay, and you are using pointer or reference about base class, then must define the destructor as a virtual. Okay, this is that. Yes, this is the same coding. Okay, this is just one extra thing, that a final keyword. If you want, here is another one, I think some. Okay, final keyword, override and final keyword. So this is the new changes in C++11. Before C++11 there was these two words doesn't exist in C++. It is uh, added newly now. So what does it means? That you see, these two words help to prevent the subtle error when overriding virtual function. Okay, so sometime if you want override that some function must be override, okay, then use the word override. How? You see, here is used, here is not used. You see, this is the first version. You see, this function a has argument integer argument, and the base class has the same function a, but the argument is different one. Okay, so it will have the same glitch and the same problem. But here, if you want that this function must be override to perform the polymorphism behavior, that if you see, if you want to make sure 100% make sure that this function must be overridden to perform the polymorphic behavior, then you see, with the same virtual word, use the word override. Okay, that this will be override. And if you want to stop this behavior, that nobody should use this function as a polymorphic, then use the word final here. Okay, final. So it means that this is the final version, it will not overridden in parent class. So these are two new classes. Yeah, preventing, you see, preventing member functions from being overridden, then just use the word final, that this is final class. Okay, now last topic of today, abstract base class and pure virtual function. Now we already discussed polymorphism, but to make the polymorphism very perfect, okay, then we need uh, something else also, which is called abstract base class and pure virtual function. Okay, so what is a abstract base class? Abstract base class cannot be instantiated. What does this mean? It means that this is such type of a class that we cannot create object of this. No object is allowed to create of this of abstract base class. Okay, so how we will create such a class that become abstract base class? So if we define a pure virtual function in any class, then that class become abstract base class. So what is pure virtual function? Okay, pure virtual function, let me see the coding. Okay, I think hopefully will be clear this thing or not. Okay, any one of you, let me define once again. Abstract base class is such a class which whose object is not allowed. It is just a, a, a class, a very, very general class, and we cannot create object of this. So the question is that if we cannot create object of this, why, what's the benefit of this class, why we are defining? So the benefit and the main purpose or objective of this class is that this class will be only used for inheritance. Okay, this will be the top level general class, and many classes will be only inherited from this class, and we will not create any object of this one. So how to make any class abstract class? We will create a virtual function in that, and we'll make that virtual function as a pure virtual. So what, how to make a function as a pure virtual function? You see, when there is any function, for example, show, what we were discussing pure virtual function. So you see, this function show info is a virtual function. At the beginning we have written virtual. So to make this one pure virtual, we will make the whole function, the everything equal to 0. So if you do like this, then the whole function become pure virtual function. Okay, and note the point that pure virtual function don't have any definition. It doesn't have any body. Okay, only this thing that you see, virtual void show info equal to 0. So until now I think you never see that function can also be equal to 0. Mostly we are assigning variables, assigning 0 to our variables, but until now we didn't assign 0 to a function. So it doesn't mean that we are actually assigning 0. So it only means for the compiler that this function is now pure virtual function, and any class which contain this function will become abstract base class. Abstract base class is such a class that only other classes will be inherited from this, and no object can be created of such class. Okay, now this is the coding, all those stuff. So I have already done this one for you. Let's go to the projects. Let's go to the project abstract base class pure virtual function. Yeah, so this is the coding. You can see, I will share with you. Copy, and here, yeah, this is the coding if you want to get. Okay, now here the idea is, the coding is about what? The idea is that we are going to define one student class, and you see the student idea is very general idea. Student may be of class 4 also, class 10 also, class 11 also, O level, A level, all these are student, university student, even master and PhD student. So student is a very general concept. Okay, so we will make this general concept as a abstract base class. How? You see, class student, these are the general characteristic of a student. Every student has name, ID number, year admitted, okay, and the constructor, okay, overloaded constructor and set function and get function, okay, all these get functions. And look at this one, this is the point that we are looking for. You see, virtual int get remaining hours, get remaining hours. and const means that the function is constant. The const is not compulsory. Okay, you can remove this. It is not compulsory that every pure virtual function will have const also. No. uh, but it is just a function for mostly for display purpose, so we are using as a const. So you see, in a parent class we just define this function, we just declare this function and equal to 0. So now this is a pure virtual function, and because of this pure virtual function, the whole class became abstract class. So abstract class means that we can only inherit classes from this. We cannot create object of this. Okay, after this, just a few constant variables, then another class computer science student, and inherit it from student, and this student is the abstract base class. Okay, this computer science students, the same constructor. Okay, you see this one is the set hours, set cs hours. The only thing is that you see the virtual function, the same get remaining hours, is here virtual but not pure virtual. Note the point. In a child class, the same function is virtual function but not pure virtual, because if here also we make it a pure virtual, then this class will also become useless. We cannot create, I should not use the word useless, we cannot create object of this. Okay, so here is simple virtual object. Okay, and here is the definition of the same virtual object outside the class. Okay, and now here in int main we are creating computer science student. Okay, and then student dot set math hour, student dot set computer science hours, and the other subject hours, and can display. So you see, here is nothing new. The only thing is that the parent class, that we created, we cannot create object of that one here. Let me run this one first. Okay, then I will show you that we cannot create object of that. So the base class, you see all the values are displayed about that. So the base class is only used for inheritance purpose. And why? Because it has a pure virtual function. Okay, let's try here in the main, that can we create student is the abstract base class name. I want to create an object obj of this. Let's suppose just create object. Let's try to run. You see the error says cannot declare variable obj to be of abstract type. You see, abstract type. The parent class student is abstract class. You cannot create object of this. Okay, so this is the purpose of pure virtual function. And mostly when you are dealing with a big project, then we need some abstract classes. The most general concept, we make that as an abstract class. Okay, and after that we inherit classes from that. For example, in real world, like the concept of product. Okay, so product is a general concept, but there are thousands of products that you can inherit from there. The companies will have many products, so the each product will then inherit it from the general concept. So this was the last topic for today. Any confusion, any question until now?